right. Hi, folks. Welcome back to Physics with Captain Rod. Give me a moment here. I think these are -3, 18, and 19. Okay. So I'm going to cheat a little bit and talk about two of them here at the same time. So 18 here is about, one of these little like play airplanes that somebody's got a wire on and they're buzzing it in a circle. And the free body's already drawn for you. All right, so airplanes can create a force called lift. The wings basically, they create pressure differences between above and below the wing, and that's what we call lift. And the plane is kind of tilted, that's why they've got an angle here. And then it's attached to a string or something, so they put a tension on it and a gravitational force, mg. So the free body's done. That was kind of nice. Now, what you have to kind of realize, the super important part of this problem is the acceleration direction. This plane is going in a circle, but this is like a side view. Its actual motion is like kind of back and forth like this. The center of the circle is like here. That's kind of an important thing to realize. So the acceleration direction for the plane is this way, and that is a centripetal acceleration, or what I call v squared r over r acceleration. So from the free body, you can write two different equations. Right? One, the sum of all forces in the y direction is equal to 0. The plane is not accelerating this way at all, right? Just to the left. And then the second, sum of all forces in the x direction, calling left positive, is equal to ma. Now, why left positive? Because the acceleration direction of the plane is to the left. That's one of my standard, put an acceleration on there. That's one of my standard, I call them carrots, Captain Rod's rules of thumb. Identify the acceleration direction, call that positive. So anything left for this has to be just algebra, because those are the only two physics equations we can write for this problem. So write those two equations out, put in all the numbers that you see, and you should be able to get this thing figured out. All right, let's chat about 19, which is about this car here going over a hill or something. Now, one thing you want to sort out, you always have to ask yourself, is this about like the car or the driver? Let's see, mass of the car is given. What force does the road exert on the car? So this problem is about the car, okay? So draw your free body. There's a gravitational force, hopefully that's obvious. Now, there's technically 4 normals, there's 4 tires, but it's very common for us to just group those together into one normal. Ask yourself, which way does that go on the car? Hopefully it's obvious. Now look at the motion of the car, right? If this car were traveling a path that was perfectly straight like this, at constant speed, it wouldn't be accelerating. But it's not traveling that path. It's traveling a curved path. So ask yourself, 1, is this car accelerating, yes or no? Right? Based on, look at what the velocity is doing, and look, right before, right at that instant, right kind of after, right? And then the acceleration, right, if it's circular motion, is a v squared over r acceleration, or a centripetal, and then ask yourself the direction. Right? And the direction is always towards the center of curvature. So think about in the picture, where would the center of curvature be? Now, my standard rule of thumb, right? Write a force equation. Sum of all forces equals ma. And as far as the direction, ask yourself which way is it accelerating and call that positive. Then write out your force equation and you can solve for, like this one right here, they're looking for the normal force. Now, as far as the direction is concerned, keep in mind it says, let's see, does the road exert on the car? That's kind of important for the question, as opposed to on the road. Right? This one's asking for on the car. Part B, where it says, what is the maximum speed the car can have without losing contact with the road? So ask yourself, if the car started to lose contact, what would change in the equation that you write for this? There's something very specific that'll change. And then move forward. All right? That should get you through both these problems. Have a great day.